So very good morning to you once again. Today let us try to continue the subject mechanics that we have started yesterday. So we are conducting a session on physics mechanics. So we will be doing other topics as well. So we have done part 1 yesterday. Today we will be doing some other questions and concepts. So make sure that you open your books, note down the problem, try to solve it and get back to me if you have any doubt in concept or problem. See, questions are being repeated like anything. Same questions are not being repeated. Similar concepts are being repeated. So here question along with concept is being explained. So make sure that you use this opportunity. Okay. So let's start with the question. So people online, good morning everyone. So as you are aware of that, a revision session is being carried out for physics since a week. First we started with first year formulas, next second year formulas, next first year concepts with problems, then second year concepts and problems. Now we are trying to focus on expected questions for JEE main season 2. So as part of that, we have started yesterday with mechanics and today we are continuing with mechanics. So open your books, try to solve the questions and get back to me if you have any difficulty. So not just the questions, the concepts are also being explained along with the questions, because not questions are being repeated, concepts are being repeated. So people watching online, comment your answers. Come on, let's try to do this question. So a root 34 meter long ladder weighing 10 kg leans on a frictionless wall. First, how to attempt a question? First, try to note the keywords. Frictionless wall, first keyword. Its feet rests on floor 3 meters away from the wall. This is the length, okay? As shown in the figure, if F of F and F of W are reaction forces of the floor and the wall, then the ratio of those both reactions is being asked. Basic, simple, fundamental question. Note down the question, note down the data, try to recall the formula, apply it, solve it. See, this question is being repeated like anything. So there is a very good chance that you can see this question in your session. So similar concept question will be asked. So you are not just covering the question but also the concept behind them. Come on. So come on, people watching online. So one of them is saying option C, okay? See, here we are there to learn the subject. Try to put pen on paper. You can use cheat codes in exam, but try to learn the subject, because we are not here to just explain the problem but also concept behind them, okay? Come on. Come on. Try to solve the question. So how do you approach this? So first try to draw the free body diagram for this ladder. How do you draw the free body diagram? Draw the free body diagram for this ladder whose length is root 34. What is the option? C, not C or D. This is not multi-correct. Single correct question. So what is the angle? What is the angle made by the triangle? Even I don't know, I need to solve, okay? Come on, how to solve it? Draw the free body diagram. So how do you draw the free body diagram? So what do you mean? Okay, still what all forces? Okay, half attempted. Uh, come on. Chalo, come on, try to draw. Still, what all forces do we have on that? One is mg. Still, it is leaning against a wall. So normal force because of wall. And it is on the floor as well. Normal force because of floor. The wall is frictionless. So do we have friction? No. The floor is friction. Floor have friction. So what is the direction of friction? See, come on. See, come on, people watching online. Yes. Okay, let's check. People are saying option C. Let's check whether it is correct or not. Okay. See, how do you draw free body diagram? 1 mg. Okay. See, one force is mg. The reaction due to wall on ladder, perpendicular. Okay. This is the another force. The reaction force due to floor on the ladder, perpendicularly up. So it is trying to slide. So this is the wall. It is trying to slide this way. So what is the direction of friction? Fs. Okay. This is Fn. So what is this side at least? What is this side? What is the height of this side? 5. Okay. So we have 1, 2, 3, 4 forces, right? So he is trying to ask the ratio of Fw and Ff. So as there is no friction on this end, there is no, as it is frictionless, we don't have any friction force, so only one force. So we have two forces here. So what is this Ff? Ff is the reaction force. Nothing but combination of Fn and Fs. So how do you write Fs? Fs is equal to under root of Fn square plus Fs square plus 2 cos theta. Theta 90 gone. So here we got F. Here we got Ff. Okay. So we are done with Ff. Next. So how do you find this Fw? So what can be applied so that we can find this Fw? See, we know length, we know mass. See, try to apply torque about O, so that as the body is in equilibrium, torque about O will be 0. So mg into this perpendicular distance, Fw into this perpendicular distance. How much do you get? Come on, I am trying to give you hints. At least now you should solve. So try to find torque about O and tell me what is Fw. See, you know this length, you know this length. So come on, people watching online, what is Fw? So what do we get for Fw? Torque about O is equal to 0. We know this length, we know this angle as well, this length. So we have almost everything, just substitution. Torque about O 0. How do you apply torque about O? What do you get Fw? See, how do you apply? Fw into what is perpendicular distance from 5? Huh? Is equal to what is mg? 10 kg, 100 newtons. What is mg distance from O? Perpendicular distance. Root 34 by 2 cos theta. This length. Nothing but 1.5. Half of this. Okay, even if you take root 34 cos theta by 2, you get 1.5. Hundred into 1.5. What is Fw? Thirty newtons. Huh? We got Fw. So one we got Ff. Fn square plus Fs square. What is Fn? Mu times n. Solve. See, Fn is equal to mu times n, right? Do we have mu? No. No. So how do you find Fn? Sum of vertical forces is equal to 0. Fn is one vertical force. What is the other vertical force? mg. So Fn is equal to mg. See, everything is given here. What is Fs? Sum of horizontal force is equal to 0. One is Fs. What is another one? Fw. See, two vertical, two horizontal. So Fs is equal to Fw. See, everything given, nothing to worry. Fw 30. Right? So, how much do you get? Fw by Ff, right? 30 by under root of, what is Fn? mg, 100, okay? Fn square, okay? 100 square. Plus Fs is equal to Fw is equal to 30 square. How much do you get? Come on. So I guess it is C, I guess. 3 by root 109, you will get C. $30, right? 100 goes come and 0 goes out. So this is how you need to solve the question, right? So if you are aware of free body diagram, you can solve this. Nothing much. We just try to find the forces and apply here. Okay? So come on. Okay. Let's try to do other problems. Come on, people watching online, let's try to solve this question. A particle of mass m is moving in a circular path. So mass is given, first keyword, moving in a circular path of constant radius such that its centripetal acceleration is varying with time. Centripetal acceleration relation given. The power delivered to the particle by the force is dash. So try to attempt. So Mr. Karthik, what are you answering for? I guess we are with new question now. Try to solve this. So try to answer that question. And try to solve the question. See how to approach this question. Huh? So the question is power delivered to the particle by force acting on it. So what are the formulas for power? See, if you know the formulas for power, still work done by time is 1. Still, see, one is work done by time. See, how do you write power as well? Force into velocity, right? So you can write power as force into velocity. So how can we find force? Acceleration given, mass given, force is equal to ma. Then power, then differentiate. See, first find force, nothing but mass into acceleration. Power, force into velocity. Force into velocity also gives us power. Try that way. See, what does centripetal acceleration gives? What is the formula? V square by r. Centripetal acceleration is equal to V square by r. From there you can find V, right? So I guess I give almost entire answer. Like, try to find the option. How do we solve this? So here again people are saying that answer option C. Let's see. See what is this centripetal acceleration? We have A is equal to k square r t square, right? So what does we get? V square by r, right? Centripetal acceleration is V square by r. What is V? KRT, okay. So here power is being asked. Power is equal to force into velocity. So we have AC. So force is equal to mass into acceleration. So is this A and this A same or not? Check. So is that A, this A same or not? See, this is tangential acceleration. This is centripetal acceleration. So how to solve this? So what all formulas do we have for AT? Tangential acceleration. R alpha. So how to proceed? So we have V readily. So once we are done with AT, we can close the question. So how to find? So this is R alpha. So come on people watching online. See, this is velocity is KRT, right? Can't we find acceleration from here? Mobile inside. So what is the acceleration from velocity? What is the acceleration from velocity? What is the acceleration from velocity? See, differentiate velocity, man. Velocity, if you differentiate, you get acceleration, right? What is this? KR. Substitute here KR. MKR, KRT. M K square R square T. MK square R square T. See, so simple, easy question. You people are looking up, down, front, back. Huh? So direct, see once you are aware of that this is centripetal and this is tangential, you can make out the question. There is nothing much special in it. So come on people watching online, comment your answers. So let's try to cover the concept behind it as well. So a body moving in circular motion. What are all the forces do we have? One is normal force, that is centripetal force, tangential force. Okay, this is mv square by r. We have just seen. This is r alpha. Okay. So what is alpha? D omega by dt. This can also be written as mr omega square. Still, what all concepts do you know about body moving in circular path? What is the resultant? So it makes an angle alpha. Alpha is equal to tan inverse opposite AD by AN. Okay. Still, so these are the basic concepts if you try to look at. So come on, let's try to go for next question. Motion of a particle in xy plane is described by following equations. The path will be dash. See, there are two equations given for x component and y component. Try to find the path of the particle. Put pen on paper. Try to have some proof for your answer. Come on. So come on. Try to solve them. ఒక 10% 20% ఎక్స్ట్రా చేయొచ్చు మీరు, లేదంటే లైట్ ఇంకా. Try to solve. How to approach this question? First try to note down the question. How to see, the question is what is the path followed by the particle? So let's try to decode the question, okay? Yes, Mr. We are trying to cover the questions from all previous years and similar concepts. So make sure that you try to do them and clear your concepts. Please get back to me if you have any doubts as well. So here given, see, how can you write omega t as? What is omega t? How can you write omega t? You can write it as theta, right? Omega, what is omega? Radians per second, theta per second. Theta per second into second, theta. So I can write it as theta. So the question looks so complex, right? Let us try to simplify it. See, how can we write this? X is equal to 4 sine pi by 2 minus theta, right? 4 cos theta. What is sin 90 minus theta? Cos theta. See, we are doing nothing, we are just trying to simplify it. What is this? Y is equal to 4 sin theta. In which path the particle follow if it has such notations? You might have come across this many times. So Mr. Harsha. So Mr. Harsha, hi, hello, good morning. Try to do the questions. See, see, see what is the x component of this point P? Hmm. What is this particle which is at a distance r? P cos theta, right? P cos theta, P sin theta. Which means that this particle is moving in a circle. So even this representation resembles this, right? Which means that this is circular. Okay? So how to solve this? So come on, people watching online, try to comment your doubts. See, not just the questions, the concepts behind the questions are also being covered, because concepts are being repeated, not just questions. So like the session, share the session so that many get benefited. We are doing it for free. So your likes really encourage us to do more such sessions. So do subscribe to Roots Academy and stay updated. So we have many such sessions for both maths and physics, chemistry as well. So like the session and encourage us, it really motivates us. So try to solve the question and get back to me if you have any difficulty. Come on, people watching online, try to comment your answers. See, a position vector of mass 1 kg object is given. See, one keyword mass is given, whose position vector is given, velocity given. He's asking to find the angular momentum. So what all formulas do we have for angular momentum? So one is MVR, still I omega, right? Still any formulas for angular momentum? So here R and V is given. So he is trying to ask the magnitude. Is angular momentum a vector or scalar? Scalar. Is angular momentum scalar vector? So you are saying that angular momentum is scalar or not? See, angular momentum is a vector. So we have angular momentum. Angular momentum is a vector, okay? C mass into R bar cross V bar. So how to solve this? Try to find the cross product. So when two vectors are given, how to find cross product? How to find cross product when two vectors R bar and V bar given? Come on, give me the answer. So people are saying, see, there are no options here, okay? So try to find cross product. See, how do you solve it? I, J, K. What is R? 3, minus 1, 0, 0, 3, 1. Okay? Now what do you get? Minus 3J. So he is asking magnitude. So we got angular momentum. So magnitude. So how to find magnitude? When vector given, how to find magnitude? 9K. 9K, minus 1, minus 3, 9. So when vector, so what is your answer? 91. So you are supposed to know the cross product, how to do a cross product. Then you are done. So try to solve this basic simple question. A man of 60 kg is running on the road and suddenly jumps into a stationary trolley. Car of mass 120 kg, then trolley car starts moving with velocity 2 meters per second. The velocity of running man was dash. Yeah. See, mass of man is given. Mass of trolley given. Velocity of trolley. Find the velocity of running man. See, basic fundamental question. So what is the concept involved here? Come on, people watching online, comment your answers. So people watching online, try to answer the question. So people watching on app as well, comment your answers. So Dikshita, Rahul, Mamata, Shiva, come on. So what is the concept involved here? So what is the concept involved here? Which concept do we use? Hmm? Topic does that question belong to? Okay. There are many parts in mechanics. Mm. So how to solve it? See, a man of 60 kg is running on the road and suddenly jumps into a stationary trolley car of mass 120 kg. Then the trolley car starts moving with velocity 2 meters per second. The velocity of running man was dash as he jumps onto the car. Try to apply the principle of conservation of momentum because there is no external force being applied. So apply the conservation of momentum. What is initial momentum? There are two objects, man and trolley. Final objects, man and trolley. Try to apply conservation of momentum between them and answer your question. What does conservation of momentum say? So first, how many types of conservation of momentums are available? Angular momentum conservation, still linear momentum conservation, right? So the answer 4, huh? 4, check. See basically there are, first let us try to solve this problem and get to the concept, okay? See here, linear momentum is conserved. Okay, let's check. So your answer is, what is your name? so people will get to know. Huh? What is your name? Manikanta. Okay, Mani. So Mani's answer is 1. Let's check how fast, how accurate is Mani. Okay. So come on, people watching online, let's see how Mani's correct, how correct Mani's answer is. So when is linear momentum is conserved? When no force is applied, right? See, when there is no external force, momentum is conserved. So what is the other type of momentum? Angular momentum. So when no external torque, angular momentum is conserved. So what is the formula for linear momentum? P is equal to mv, right? So how about angular momentum? mvr. I omega. So here as there is no external force being applied, we can apply this final momentum is equal to initial momentum. P final is equal to P initial. So what is P initial? M1 V1 M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. See, what are the values of U1? U1, I am initially trolley is at rest, right? So mass of man, what is the mass of man? 60. What is his velocity? Given man, he is running with some velocity. Okay, right. So here unknown, right? So what is M1 again? 60. So both are moving with same velocity once he jump into the trolley, right? 60 plus, what is the trolley's weight? Moving with velocity 2. So what do you get U1? So that's how we need to proceed. So Mr. Manoj, your answer is wrong. Please check. So come on, people watching online, comment your answers. Do share your doubts so that they get clarified. Not just the questions, but also the concepts behind the questions are being explained. So we got the velocity of 6 meters per second here. So let's try to discuss the concept behind it. Yes, we are trying to discuss the same. So conservation of momentum. So you can shortly expect a question from this concept in any given exam. So where do we apply conservation of momentum? We apply in collisions. Conservation of momentum is being applied in collisions. So what are type of collisions? Basically there are two types of collisions. Elastic and inelastic. Basically there are two types of collisions. One is elastic. The another is inelastic. So what are all conditions about elastic and inelastic? See, conditions for elastic and inelastic. So come on, people watching online, we are trying to cover the collisions concept so that questions are being repeated in it. So try to answer my question. What are all the conditions for elastic and inelastic collisions? Okay, see, in both collisions, momentum is conserved because no external force is being applied. Okay. So in elastic collision, what is the value of E? 1. How about in inelastic? less than 1. Okay. So what is E? What does E stand for? E is nothing but coefficient of restitution, right? So what does E stand for? What does E stand for? Formula for E. So come on, people watching online, comment your answer. See, E is nothing but velocity of separation by velocity of approach. Okay. So what do we get? Okay. So this is one condition for elastic and inelastic. So other conditions for elastic and inelastic. Come on. What are all the conditions for elastic? How about kinetic energy or total energy? How can we comment on energy for elastic and inelastic collision? Is the energy conserved in elastic or not? So in elastic, energy is conserved. Kinetic energy is conserved. So how about in inelastic? Is kinetic energy conserved or not? Okay. Only in elastic collisions, Ke is conserved. So in inelastic, no conservation. Okay. Still, what all do we have for collisions? So what do you mean by plastic? Plastic collision. So what do you mean by plastic collision? What do you mean by plastic collision? So in plastic collision, E is equal to 0. That means there is no velocity of separation, which means after collision both the bodies move together as single unit. Okay. So in question, if he represents any kind of plastic collision, it means that body moves together after collision, like there don't be any separation. So this is about collisions, conservation of momentum. So this is about collisions, okay? So let's try to do next question. Okay, try to do this. Say hanging mass M is connected to 4 times bigger mass by using a string pulley arrangement as shown in the figure. The bigger mass is placed on horizontal ice slab and being pulled by a 2 mg force. In this situation, the tension in the string is okay. First, let us try to draw the diagram. I guess the diagram is something this way. So, diagram missing. Let me draw the diagram. So, how to draw the diagram? So, see, try to answer the question diagram given. So, this is the figure given, actually it is missing. See, a hanging mass M is connected to a 4 times bigger mass by using a string pulley arrangement as shown in the figure. The bigger mass is placed on a horizontal ice slab and is being pulled by 2 mg force. In this situation, the tension in the string is x by 5 mg for. So this is the tension. Tension is being asked. Neglect the mass of the string, friction of the block, ice slab, etc. and try to find the string tension. Come on, people watching online. So how to solve this question? So how do you solve that question? See, a mass M is. So in which way do you think the block move? Will it move towards left or right? Huh? Right? If right, why? If left, why? See, a hanging mass is connected to 4 times bigger mass by using a string pulley arrangement. So what is the net force towards left? Hmm? So what is the net force towards left? What is the net force towards left? How about? See, this T and this T is same because it is of same string, okay? So they form internal forces. So will the system move with same acceleration or not? Will both blocks move with same acceleration or not? So yes, both blocks move with same acceleration. Now let's try to find the net force, okay? So towards left it is 2 mg. So what is towards right? mg. T nothing but mg. So how to solve this? So first we need to find the net acceleration. M total. F net by M total. What is M total? 4 plus 1, 5. 4m here, m here, okay? So 5m. So what is net force? The net force will be 2mg towards right, 2mg towards down, so it becomes mg. M total is equal to 5m. It becomes g by 5. So we got A net acceleration, g by 5. So what is the tension? Let us try to apply for this block. We got A net, right? Let us try to apply A net for this block. So what are all the forces acting on this block? One is T and the other is mg. It is moving up with m into A net. So T minus mg is equal to mass into A net, g by 5. So how much do you get? Six mg by 5. So what is x? 6, right? So mg 5 by 5 given. So x is equal to 6 newtons. See, simple fundamental concept. Once we try to find the A net, we are done. Because the entire body moves with same total acceleration, okay? So let's try to go to next question. So a small toy starts moving from position of rest under a constant acceleration. If it travels a distance of 10 meters in t seconds, the distance traveled by the toy in the next t seconds. See the keywords given. From position of rest. From rest it started moving under constant acceleration. Okay. So it travels a distance of 10 meters in t seconds. The distance traveled by the toy in next to t seconds. See, basic question from kinematics. So 20. 20. Okay, still any answers? Have you solved it? Then try to solve, answer basic fundamental question from kinematics. Then what all? Then what all do we have? See, basic fundamental question from kinematics. Just apply the Newton's law of motion. You are done. Do man. To show me then. If it is so easy, then I will solve, okay? Then let's check. Try to rectify or 10, okay? Let's see. How about you? Basic kinematics equation, V is equal to U plus AD, S is equal to UT plus half AD square. You apply them, you will get. See, put pen on paper, show me the answer, not just orally, okay? Come on, how about you? Huh? Doing? Do? How long will you take? Hmm? It's starting from rest. See, what is initial velocity? Next. So, moving with constant acceleration, right? Distance traveled given s, right? What is the distance traveled in next t seconds? T seconds. Hmm? Already taught. Over, no teaching. See, the question is the distance traveled by the toy in next to t seconds. So S2 is being asked. Okay? So what are all given? A small toy moves with a position from rest u is equal to 0. Under a constant acceleration a. If it travels a distance of 10 meters, S1, S in t is equal to 10 meters. The distance traveled by that toy in next to t seconds. So how to solve it? See, we have a time t. We need to have a time 2t. Find distance at 2t and subtract 10 from it. First try to find t. What is t? What is the value of t? So hi people watching online. Try to answer the question. Do like, share the session so that many get benefited. See, what is this? S is equal to ut plus half a square. S is equal to ut 0 half a t square. Okay, we have one such equation. So at 2t we need to find st2 st2 is equal to half a 2t whole square, right? We have two such equations. What do we get from here? 4 half a t square. So what is half a t square? So what is the question? The distance traveled by the toy in next to ts. So we got for 2t. From 0 to 2t, 40. From 0 to t, 10. So what is the distance traveled from t to 2t? It's 10, 30. See, in first t seconds it traveled 10 meters. In total 2t, it traveled 40 meters. So he is asking what is the distance traveled by the toy in next ts seconds from t to 2t. So just solving the question is not important. What is being asked is also important. So basic fundamentals of kinematics. Let's see what are all formulas do we have for this kinematics. So if you try to recall, so V is equal to U plus AT, come on. S is equal to, okay, okay, displacement in nth second. What is the displacement in nth second formula? U plus A into n minus half. Okay, still what all do we have? See, this is from linear motion. How about rotatory motion? Omega final is equal to omega initial plus alpha t. Okay, theta is equal to omega initial plus half alpha t square. Okay, omega final square minus omega initial square is equal to 2 alpha s, 2 alpha theta. So in a similar fashion, omega in n second, displacement in n second is equal to initial plus acceleration n minus half. Still, what all formulas do we have from this basic kinematics? See if you can try to recall. So what all formulas do we have? See, when displacement given, how to find velocity dx by dt. So hope you all are aware of this acceleration dv by dt. Okay, so we will be following these basic fundamentals. Let's see. Okay, try to answer this question. A block of mass 40 kg slides over a surface when a mass of 4 kg is suspended through an inextensible string passing over a frictionless pulley. See, the moment you read the question, you are supposed to identify the keywords. The coefficient of kinetic friction between the surface and the block is mu k is given. Surface and the block, mu k, 0.02, okay. The acceleration of the block is being asked. So people watching online, so similar question we have done just before 10 minutes, I guess. So you are supposed to answer this question. Even if you don't know anything from today's session, you can answer this question. Okay, let's see. See, show me, not just show me on paper. Read the question. Come on. See, we have done this question just before. See, will both blocks move with same accelerations or not? See, 40 kg is connected to 4 kg or a single spring, okay? Single string. The coefficient of kinetic friction is given for 40 kg. The acceleration of the block is being asked. So how do you approach the question? See, what is the net force? Mr. Venkat. Answer is 4 by 5 and answer is 1 by 5. Huh? Okay, 4 by 5. Let's check what all answers do we get. Come on. So what did you got? 1 by 5. So first let us try to find A net. So see, as both blocks are connected to same string, they move together, right? So the given M1 40 kg, okay, M2 4 kg, okay, the acceleration of the block. So they move with same acceleration, both of them, because they are connected to same string, sorry. So let us try to find A net. That is what he is trying to ask, right? So first let us try to draw the free body diagram. This is tension. This is for 40 kg, right? What is value of N? Normal force for 40 kg block, 400 newtons. So this is the free body diagram for this one. Now let us try to draw the free body diagram for this. So how to solve it? So it is moving down, right? So first let us try to find what is Fs. Fs is equal to Fk actually, okay, Fk. Kinetic friction is equal to mu times, what is mu? 0.02 times N, 400 is equal to 8, right? So a force of 8 newtons towards left. So what is tension? T minus Fs is equal to Ma. Mass of M1 A net. In a similar fashion, we try to apply here. So we are trying to make the body into dynamic equilibrium. So we try to apply Ma here. Okay, what do we get? T plus Ma is equal to 40. Right? See, this is moving downward. So to apply my Newton's laws, it needs to be in equilibrium. So I applied a force Ma on it so that it is at rest now. So the net force on it is 0. So T plus Ma is equal to 40. T minus Fs is equal to M1A. So I know Fs 8 Newton. Okay. So try to find A from this equation. I guess you can find, right? So what do you get? M1A plus 8 T plus M2A, 40 minus M2A. So what is M1 40, right? Eight by 11. How much you got? So that is the reason I am asking you to put pen on paper. Okay? That is the reason we have pens, books, exams, time. We are not here to guess. Okay? So we get something like 8 by 11. Hope you got my question, my concept. See, how did we find? We considered the entire system moving with acceleration A. So we applied, we drawed free body diagram 1, free body diagram 2. So from these two equations, two unknowns. We have T as unknown, A is unknown. You can find tension as well. So what is tension from, we got A 8 by 11, right? So what is the tension? Try to answer tension. This is M2. This is M1. So what is the tension in the string? Tension, how much do you get? Next slide. So you get, what do you get tension as? T minus 4 into 8 by 11 is equal to, what was that? M2 into 8 by 11 is equal to 40, right? How much did you got? 472 by 11. So that's how we need to proceed. Come on, people watching online, try to comment your answers. So this is basic question. Try to solve this. Come on, try to solve the question. So, in the given figure, the block of mass m is dropped from the point A. The expression for kinetic energy of the block when it reaches point B. So, what do we apply here? So try to answer this question. So try to answer that question. In the given figure, so the block of mass m is dropped from the point A. The expression for kinetic energy of the block when it reaches point B. So the conservation of energy, apply conservation of energy. Try to apply the principle of conservation of energy. So, what is the potential energy at A? mg y. Okay, what is potential energy at B? Okay. So, total energy at A is equal to total energy at B, right? So, what is the other energy at B? Kinetic energy. So, total energy at A, potential energy plus kinetic energy. So, what is potential energy at 1? mgy. What is potential energy at 2? mgy minus y naught. What is kinetic energy? So you subtract, you will get the answer. So straight question. Hmm? Hmm? Okay. See, that is the reason I am asking this question. Come on, a block of mass m is placed inside a box, descends vertically with acceleration a. The block exerts force equal to 1/4 of its weight on the floor of the box. The value of a is dash. So how to answer this question? Basic fundamental question. Hmm? Just, come on, how to approach? See, questions are being repeated, concepts are being repeated. You can expect similar question in your set tomorrow. That is the reason I am repeating the questions. I am getting questions from here, there. Yesterday we have solved similar question. If you try to recollect. See, the concept is being repeated. See, literally, question paper is leaked. 80% paper is already out in the form of previous year questions. Same concepts are repeating. You can easily score 60 to 70 in physics out of 100 if you solve all these questions. There is nothing new in it. See, the force is 1 by 4th. The weight gets reduced to 1 by 4th. See, a block of mass m is placed inside a box. It descends vertically down with acceleration a. The block exerts a force equal to 1/4 of its weight, which means that the weight of the block gets reduced to 1/4 of its initial value. Then what will be the acceleration with which the lift or the box is getting down? Like, so first try to draw the figure, try to apply the free body diagram. Then apply Newton's law of motion for it. So, show me on paper. I don't mind. So people online, comment your answers. See, generally, let's try to take a simple case. When a body is at rest, when a body is at, come on, concentrate. When a body is at rest, When a body is at rest, so generally when it is in rest it is mg. Here in question it is said that a body is moving down, so at an acceleration a. See where you went wrong, okay? Where you are going wrong. So he is saying that the block exerts force equal to 1/4 of its weight. Okay? So mg by 4. Right? So you agree with this? So then the value of A. So we cannot apply Newton's law of motion here directly. So we need to first let us make it into rest by m into A. Let us convert it into dynamic equilibrium. Now it is in rest. So try to find the value of A. See, what do you get? Mg minus. See how can we solve this? See, initially it was mg. As it is descending down, we are subtracting the force on it, and the final resultant force is mg4. So using this, find ma. So this next question from projectile motion. So try to answer this. Is connected to human since centuries. See, you cannot have life without physics. So all coding will be done after physics is done. So okay, even in rocket science, you need physics. Come on, people watching online, try to comment your answer, doubts. ఏదో వాళ్ళు అట్లా చేసిర్లే మనకెందుకు. Come on. You can throw a ball up to a maximum range of 100 meters. How high can he throw above ground using the same ball? Come on, try to apply formulas of projectile motion. Hope you are aware of projectile motion, right? See, what is the formula for range? What is the formula for range? Check, open your books, check. Write the formula for range. Range u square sine 2 theta by 2g. What is h max? Maximum height thrown. What is the formula for h max? U square sine square theta by g. So try to apply that formula and try to find how high can the ball be thrown above the ground. See, what is the condition for range to be maximum? What is the condition for range to be maximum? See, listen to my question first. What is the condition for range to be maximum? Huh? So the question says that so basically we have 4 different paths here. So which path do you think has maximum range? Huh? Which path? So maximum range. Range is nothing but the horizontal distance traveled, okay? So for range to be maximum, theta should be 45 degrees. When theta is equal to 45, range will be maximum, okay? So then apply the formulas. So what is R u square sin 2 theta by g. H max so this is given as 100. So what do you get? Sin 91, right? U square by g. U square by g is equal to so 25. Hope you got the question. So that's how you need to get the answer. So let's try to look at the formulas of projectile motion as we are covering the topic. So people watching online, S25 command, Varalakshmi, you are right. So we are trying to ఇవన్నీ రావు మళ్ళీ చూద్దామా. Come on, try to answer this question. So two balls A and B are placed on top of 180-meter tall tower. Ball A is released from top at t equal to 0 seconds. Ball B is thrown vertically down with initial velocity u at time t equal to 2 seconds. After certain time, both balls meet 100 meters above the ground. Find the value of u. See, we had done similar question yesterday. See, what are these keywords? See, two balls are placed on top of 180-meter tall tower. Okay. Ball A is released from top at time t equal to 0. Ball B is thrown vertically upwards. So ball A is released from top. Ball B is thrown vertically down with initial velocity u. After time t equal to 2 seconds. So both balls meet 100 meters above the ground. Find the value of u. So see similar concept question has been done yesterday. Try to answer the question. We had done 3 to 4 models on same concept since yesterday. So try to answer this question. So two balls are given, 180 meters height. So try to answer the question, use basic laws of kinematics. So what is the value of u? What is the value of u? How do you find? See, apply Newton's laws of motion. Where u, v, s, we have 4-5 variables. Apply whatever you know, apply, find, tell me the answer. So you are saying 30 seconds, See, for first ball, see, I am trying to give you hints, try to follow it. So what do you find for ball A? 180 minus 100. So for 80 meters, try to find the time taken for ball A. Okay? A. For 80 meters, to travel a distance of 80 meters, find the time taken for ball A. In the similar fashion, apply it for ball B as well. You can find value of u. So come on, let's try to do this question. So people are saying D. Let's check. So people online are saying D. How about you? Any answers? D. Okay, still. See what is being asked. Come on, come on. See, even if you don't know, if you try to concentrate, you can make such questions, okay? So this is the fourth question we are doing since yesterday, similar concept. So tomorrow, there is a very good chance that in your session you can expect question. So, find the initial velocity. So how do you find? See, what is the time traveled? See, what is the time travel for A to travel 80 meters? Four. This is TA. This is TA. So here it takes 4 seconds. So it is 2 seconds late. So for it to travel 80 meters, it takes just 2 seconds. So what do you find? So what all equations do we have so that we can find u? See, we don't need total t actually. So for time t is equal to 2 seconds, it travels 80 meters. See, for B, we have time and distance. Time, distance, find u. Apply this equation. Tell me the answer. White shirt, come on. Have you solved it? T half 2 square అది ఏం వేసినా 4 ఓకే చూద్దామా come on white shirt. So let's check 2u plus 10 by 2 5 4 s is equal to 80. 80 minus 20 60 by 2. Let's see. Okay, definitely we'll try to post the PDF as well. Come on, people watching online, try to comment your doubts so that we can clarify it. We are not just discussing questions but also the concepts behind them. So do like the session, share the session so that many get benefited. Your likes really motivate us and helps us to do more such sessions for free. So yes, let's try to go for next question. So a body of mass m at rest explodes into 3 pieces in the ratio of 1:1:1. Two smaller pieces fly off perpendicular to each other with velocity 30 meters per second and 40 meters per second respectively. The velocity of the third piece will be, let's try, see, to which concept does this question belong to? See, there are three masses, 1:1:2. Two smaller pieces fly off perpendicular to each other. So what is the principle that we try to apply here? Which principle do we apply? What is that concept? Okay, 25. Let's check. Come on. So what is the principle applied? So which principle do we apply here? See, what is the principle that we try to apply here? Come on, people watching online. See, conservation of momentum. See, conservation of momentum is applied whenever explosion takes place, because there is no net force being applied. There is no net force is being applied here. So the ratio of masses, so final momentum is equal to initial momentum. So what does it say? Three masses are of ratio m1:2, m2:2, m3, 1:1:2. So initially it was at rest. So what is the initial momentum? 0. So final momentum also should be 0. So that is what we can make out two smaller pieces fly off perpendicular to each other with velocity 30 meters per and 40 meters per second. So let us consider them as masses of x is to 2x. So one is moving, the two smaller pieces fly off perpendicular to each other. So let us consider got exploded. So try to apply this principle, like this is of mass x, this is of mass x, they got exploded and moving along in perpendicular direction with 30, this is 40. So what is the velocity of the third piece such that net movement will be 0? So how to solve this? Come on, people watching online, try to comment your doubts. You try to equate the x components and y components. You can solve, I guess you will get somewhere B or C. If you try to equate them and you solve it, you can make out. So you will get x and y component of V, then find the resultant, that will be the answer. You need to solve it, like it will be B or C, somewhere in between B or C. So try to answer this question. A block of metal weighing 2 kg is resting on a frictionless 2 kg frictionless plane as shown in the figure. It is struck by a jet releasing water at a rate of 1 kg per second at a speed of 10 meters per second. Then the initial acceleration of the block will be. Yes, you want question? Okay. Hope you have a look at the figure. This is the figure. So I am keeping the question for you. Figure is so simple. Acceleration is being asked. Come on. Come on. Try to answer that. Hope you have seen that figure to which Hmm? Options. We have A, C, B, D. We have options. Okay, first try to solve the question so that we'll look at options later. First try to understand the question. So come on, people watching online, try to comment your answer. Like, if you really find it slow, try to use it 1.2x, 1.5x and watch the video at the end. So, okay, what are different forms of force? See, you can find force by mass into acceleration, right? Rate of change of momentum. So try to apply that rate of change of momentum is equal to force applied there. So what is the initial momentum? What is the final momentum? See, water is coming out of jet at a rate of 1 kg per second, okay? So it is striking the block and its initial moment is given and final momentum is 0 along x direction because it strikes the block and splits away. So try to find the rate of change of momentum of jet and it will be equal to the block. First try to find the force applied on the block. Force applied is equal to mass into acceleration of the block. So once you find the force, so you can divide force by mass. Mass of the block 2 kg. Options A, B. Next page lo unnai. Okay, let's see. So these are all options do we have. Options A, B, C, D. See what is being asked? Initial acceleration, right? So how do you find initial acceleration? Block, right? So what is mass of block? What is the mass? 2 kg, right? So first we need to find force. If we find the force, we are done. So how to find the force? Rate of change of momentum of jet. See, what exactly happens is that jet strikes and goes away. Okay, so the momentum along x direction is conserved. See here, Newton's third law will comes into picture. Force applied on water is equal to force applied on block. Every action has an equal and opposite reaction in the opposite direction. So the force is being applied on the, so if you try to find the force applied on the water, it will be equal to the force applied on the block, the Newton's third law of motion. So what is the force applied on water? So momentum change of water along x. So mass flow rate into final velocity 0 minus initial velocity. What is the initial velocity? V. How do you find V? We have flow rate, right? So how do you write this? mv. Q is equal to av. V equal to Q by A. Okay. So okay, see, we are trying to find force applied on water, which will be equal to force applied on block in opposite direction. So minus goes away. Even if you ignore, it works. So what are all given? 1 kg per second given. Okay, we need not struggle. M given. Still, what all given? Velocity given. V given. See, generally mass flow rate will not be given. What they will try to give is that flow rate they will give. So you need to find flow rate using area. The area of this pipe will be given. So from there you need to find velocity. So you are supposed to apply here. See, if he wants to increase the standard of the question, he can go that way. So what do we get? Mass 1, 10. So we have minus 10, I guess. So mass flow rate, it is 1 kg per second. Velocity 10 meters per second. Okay. So this is the force applied. So force on block is equal to 10. So acceleration, force by mass. What is force? 10 by mass 2, 5. So option C 1. So the second option C. So do we have next one A or B? What is A or B? How do we get different options? See, why do we get different accelerations? Try to think. Try to answer this question. We got it as 5. How about the other option? How do we get? See, like you will be having post guidance session. I get your all your queries will be solved there, right? Hope you are following Roots Academy. There are there are videos that are being uploaded daily regarding these things, like what rank you get for what. Yeah, it's in a similar way. Even that will be updated. Okay. So if you try to find, if you use those plus and minus symbols, I get you will get one more acceleration. So one is 5. So option C or D. The other option you can find by varying the plus or minus symbols. Let's move to next question. So come on, try to solve this. So a spherical shell of 1 kg mass, radius r, is rolling with angular speed omega on the horizontal plane. The magnitude of angular momentum of the shell about origin is a by 3. The value of a is dash. So how do you find it? Come on, try to. See, hardly you have 1 week more. Monday only. So make sure that you try to cover as many questions as possible, so that at least something you can improve, at least 10%. I'm helping you. See, I'm helping you right now. You are not. See, first write the given data. Try to write the formulas that you know and try to apply them. So he is trying to ask angular momentum of this shell about the origin O is dash. So how do you find angular momentum? Angular momentum. Excuse me. See, what are formulas do we have for angular momentum? I omega. Okay, right. Chalo, try to apply it. Try to apply it so that it is about origin O. So angular momentum about origin. What is angular? What is moment of inertia of spherical shell? About centroidal axis. What is moment of inertia? Formula. This is last question. We have other questions as well next. So try to do this so that we can go for next questions. What is moment of inertia of ring of radius of ring? Moment of inertia of ring of radius r. See, what is moment of inertia for spherical shell? 2 by 3 pi r square. What is moment of inertia for solid sphere? 2 by 5 mr square. For a ring mr square, disk mr square by 2. For a rectangular column. See, I guess you need to open your textbooks. In intermediate, first year textbooks, IB textbooks. You have all those, right? Come on. See here, mass 1 kg given, radius r given, omega given, The magnitude of angular momentum of the shell about origin. See, what is angular momentum? So, first let's try to look at what are the basic inertias of standard figures. C for a disk, what is See, these are the basic moment of inertias of figures you are supposed to know. Try to note down if you haven't come across or forgot. Try to remember. So direct questions will be asked from those basic moment of inertias. Huh? So try to So try to answer this question. So what is I for? So what is I for spherical shell? So what is I for spherical shell? Shell. I for spherical shell. Try to apply I for I of spherical shell here. So 2 by 3 mr square is along center. So try to apply here, it is about origin. So we need to find about origin. So what do we use? We use parallel axis theorem. Use parallel axis theorem. Shift it. So what do we get? Moment of inertia about origin. What do we get? So what is that theorem that has been applied? Which theorem did we apply so that we get moment of inertia along origin? See, the question is about magnitude of angular momentum about the origin. So this 2 by 5, 2 by 3 mr square is the moment of inertia of spherical shell along the center. So as we need to find along the origin, we need to know I along the origin. So we know I along the center. So to find I along the origin, we need to use parallel axis theorem. Parallel axis theorem says that moment of inertia along any axis is equal to moment of inertia along centroidal axis plus mass into distance, square of distance between them. So this distance between center and R is root 2R. So try to apply it and find. అయిపోయింది. Centroidal axis about origin. Come on, let's try to solve this question. Come on, people watching online, offline, come on. When a ball is dropped into a lake from a height of 4.9 meters, see, try to look at the keywords above the water level. It hits the water with a velocity v and then sinks to the bottom, the constant velocity v. It reaches the bottom of the lake in 4 seconds after it is dropped. The approximate depth of lake is being asked. Approximate depth of the lake is being asked. How did you do? Come on, try to answer. So, basic. So try to apply basic laws of kinematics. You can make the question. See, basic laws of kinematics. Height given h. You can apply s is equal to ut plus half ad square. See, until it hits the water, acceleration is applied. Then it sinks with constant velocity, which means acceleration is 0. It reaches the bottom of the lake in 4 seconds after it is dropped. So total time of travel is 4 seconds. Approximate depth. So s is equal to ut plus half ad square once again. So 2 times s is equal to half into ad square, you can make out. There is nothing much. Try to apply, solve. Come on. Apply Newton's law of motion. Put pen on paper. Come on. Note down the question. Note down the question, answer. Come on. Try to solve the question. See, apply Newton's. Okay, try to apply the formulas. See, first let us try to analyze the question given. See, a ball is dropped. See, try to look at the question. See, what is being asked? A ball is dropped into a lake from a height of 4.9 meters. Right? First statement. It hits the water with velocity v and then sinks to the bottom with a constant velocity v. It reaches the bottom of the lake 4.0 seconds after it is dropped. The approximate depth of the lake. So come on. So how do you solve it? See, first try to find the time taken here for the ball to touch the water droplet. What is the time taken? How do you solve? When height given, initial velocity. What is initial velocity? 0. Initial velocity given. What is the time taken? What is the time taken? Not total time taken. For a body to touch water. What is the time taken? So people watching online, you can watch it at 1.5 speed or 2 speed because we are going too slow. So come on. Those who watch chapter, okay? So come on. అందుకే 2x పెట్టుకోమని చెప్తున్నా. So try to find time. What is the time? What is the time taken to travel from 0 to apply this S is equal to tell me the time. So height 4.9 meters. Substitute an answer, man. Come on. Substitute an answer. What do you get? Do open your book. Come on, where is your book? Come on, what is the time taken? What do you get, T1? What do you get, T1? So come on. See, apply, find T1. What do you get, T1? T1 we get as 1 second. So this is, so what is this? 3 seconds, right? So we get is 3 seconds. So then apply S is equal to UT plus half AD square. Okay. G. हाँ हमारी. See, here there is no acceleration in case 2 because it is moving with constant velocity. So we need to find V. So how do you find V? Question is about H. So, so you need to find V. How do you find V using U? You know U, S, T1, find V. Come on. What is the V? What is the velocity V with which it travels? Come on. What is V? Because acceleration is 0. So, three, right? So depth we got as 30 meters. So why did we got that difference of 0.6? We took G as 10 in each case. So we got that difference. Last question. I guess this will be a bit easy question. So let's close the session with this. Let's close the session with this question. So once we are done with this question, let's try to close. So try to answer this question. So I actually kept a easy question for you. So what does the question say? Two blocks of masses 10 kg and 30 kg are placed on same straight line with coordinates. The block of 10 kg is moved in the same line through a distance of 6 centimeters towards the other block. The distance through which the block of 30 kg must be moved to keep the position of center of mass of the system unchanged. So how do you solve that? Present the question on paper using a diagram and try to think what exactly is being asked. See, this is a concept of center of mass. So how do you find center of mass of a given system? D, okay, how and why? So how do you solve? See, the question says that, see, two blocks of mass 10 kg, 30 kg are placed on same straight line with coordinates 0, 0, x, 0. The block of 10 kg is moved on the same line through a distance of 6 centimeters towards the other block. So how do you solve this? See, the center of mass, as no external force has been applied, the center of mass remains at rest, okay? So let us consider it as so the distance, change in distance. So try to apply the moment about some point O. Consider it as initial distance x and try to find it, try to apply a moment about some point. Take some reference, you will get to know. See, what do we get? See, let us consider this as R1, R2. Okay? So about center of mass, moment is 0, right? So 10 R1 is equal to 30 R2. So what do we get? R1 by R2. R1 by R2 is equal to R1 by R2 is equal to 3. So now the R1 is is decreased by 6 units. He is asking what is R2, how much R2 gets decreased. So R1 minus 6 by R2 minus Y is equal to 3. See, the ratio should always remain same, right? Substitute back, substitute back, substitute back, substitute back, and try to give me the final answer. See, the question is what is Y? So what is Y? Two. How much do you get? Y? A simple simplification, man. So is it towards or away? See how to decide whether we need to move towards or away. See, the momentum about O is being taken. So if we move towards O, even it should move towards O. So it should move 30 kg block needs to move towards 10 kg block 2 centimeters. So today let us try to conclude the session with this question, and we will be continuing with next sessions. So a series of revision sessions are being going on. So first we try to cover the formulas. Then next we try to cover the concept from first year and second year. Now we are trying to cover the important concepts for mains and BITSAT. So do like the session, share the session so that many get benefited. Thank you.